Hello, everyone. Yay. Thank you. We are going to talk about responsive applications. But first, hola, Alicante. I'm really excited to be here. It is my third time. I can already feel that I'm kind of like coming home. Everywhere I go, Wi-Fi automatically connects. In the hotel, here in the venue. So I hope to see you all next year as well. And this has been an amazing day. So let's give a round of applause to all of the speakers presenting all this amazing content and organizers for making us all gather together here. Yay! So, responsive. Anybody who had to build or maintain responsive web applications can agree that it sometimes can be a pain. There's often some duplicated code for different screen resolutions, dirty overrides in your styles, frequent regressions, and which causes inconsistent experience for your users, but also a lot of frustration for the team. So I hope that by the end of this talk, you'll have a few new tools at your disposal to make the whole process a little bit more easier. But first, let's unpack. What does responsiveness mean? Usually, mobile devices come to mind. But I would like to make a case that responsiveness is much more than that. It's an ability of the web page to respond to, yes, to different screen sizes and orientations, but also to different types of inputs and different device types, and also to different user preferences and settings. And we'll talk about all of this during this talk. We've got quite a lot of ground to cover, so let's start. We'll go over some of the foundations first, and then we'll have a lot of practical examples. And I want to start with text. Because of the majority of the modern UIs is just text in different colored boxes on the page. So historically, we usually define text in pixels. However, pixels are a fixed value, and currently browsers give ability for users to customize the font size that will be globally applied to all of the web pages they visit. It is an accessibility feature. My grandma, for example, uses it, and it allows to globally adjust this setting. However, pixels are a fixed unit, so they won't adjust. In order to respect the setting of the user, we need to use relative units instead. So if we define text sizes in RAMs, it would dynamically scale and adapt to user preferences. What is a RAM? A RAM means root M. So similarly to how M unit, you can get font size of the current element. With M, you can get font size of the root element, which is HTML element. Then, if we define certain value in RAMs, it will be multiplied by the root font size. So font size defined on HTML element, to get the resulting value. And if this font size is changed, which is what browser is doing when the setting is adjusted, all of the font sizes within your application are going to be dynamically updated as well. So if you want to respect the setting, instead of using pixels for the font size, we need to adjust it to using RAM values. However, if you start using RAMs, especially in the beginning, it is really hard because all of these values are kind of arbitrary. It's really hard to understand what is exactly the size. There is this neat trick that we can use using calc to just define them, divide them by 16 to make it a little bit easier to see what it's about. You can add comments. But what I prefer to do is actually define your font scale. So you just define one time globally all of your possible font sizes, and then instead of using directly font sizes, you use semantic values instead. You can also sync this with your design team in Figma, and then you just don't need to think about underlying font size at all. However, if we start using RAMs for the font sizes, we need to also understand how they would work with other elements that have fixed dimensions. So in this case, icon and a button are fixed, but the font size scales. So the UI can look kind of weird. It is a problem with a lot of web pages nowadays. So let's talk a little bit about what other units we need to use in conjunction with the RAMs in order to make our UIs adapt. So if we're defining width of the element, we generally can use RAMs for the width. However, there is also one unit that I think is very underutilized. It is ch unit, which defines number of characters that can fit. It is calculated based on the character 0. And we already know recommended character per line is around 40 to 70, so it allows you to very dynamically adjust width of certain elements based on how many characters fit. I think it's one of the most underutilized units in CSS. For height, we generally want to think, do we even need height? In many cases, min height might be what we are looking for, because it would allow content to dynamically flow. However, if we do need to define a height, we can use rem units, or there's also LH unit, which will target current line height. If you use icons within the interface, we also need to keep them legible because they're very informational. So using rem units for them makes a lot of sense. However, there's also a lot of white space in your interface. You have different paddings and margins, and here it gets a little bit more interesting. If you have space between different paragraphs, it's good to use rem units or m units, because otherwise your text can get less legible because the paragraphs will be squished. However, if you have padding that is white space within different elements of the UI, if you use rems, it will also scale with the font size, and therefore will make text even harder to read. So using fixed units there might be better. With typography, there is also additional challenge. Usually, the smaller the device gets, the closer it is held. So font sizes that look quite okay, especially for titles, on the big screen, can occupy the whole screen on the mobile. So ideally, you want to reduce them for smaller viewports. We can do it with the media queries, like here, and just redefine the font size. And then we would see this jump. When we hit the specific breakpoints, we can see that our font size adjusts. This is okay, but it can also create these weird situations in between the breakpoints. And while we could just define more breakpoints, ideally we would like the text to scale fluidly between those. For this, we can use fluid typography. CSS has this clamp function, which has really interesting application in typography specifically. So if in there we can provide a minimum value, also the maximum value, and our preferred value. And if inside preferred value we put some kind of combination of viewport units and rems, we can define the boundaries and the growth rate for our font size. This looks a little bit magical. Unfortunately, you don't really need to define these values yourself. But you can see that if you do use fluid typography, that the font size scales smoothly between different viewports. There's a lot of different calculators online. My favorite is Utopia. It kind of defines the whole system for fluid typography and space. It is really nice for static websites, but I think also fluid typography has applications in because we can use it for larger titles and display titles as well. Now, as we talked about text, I think it would be hard to talk about responsive UIs without talking about breakpoints and media queries. So let's do that quickly. So with media queries, we can target different viewports or specific sizes of the screen. And then we can adjust styles accordingly to the viewport. We can define them using the media query syntax and media keyword in CSS. By the way, right now, also range syntax is supported, which actually makes media queries much easier to read. Traditionally, breakpoints are always defined in pixels. But if we take into account the font scaling factors and if you use rems for your font size, it might actually make sense to define breakpoints in rems as well. Because then it would make sure that everything keeps readable even on smaller viewports and with larger font sizes. So we can just replace our pixel values with rems. If you use PostCSS, there's this really nice plugin that you can use to define custom media queries and just reuse them throughout your application. There's also in JavaScript, we have media API that you can call on window to make sure that whether the window matches your media query or not, and you can even listen to the changes. Using this API, we can define our own custom set of hooks. For example, we can have use media query hook, or if you define your own set of breakpoints, you can create really like the kind of use breakpoint hook. Just gets the current breakpoint using mobile first approach. And while media queries are very useful, they are quite limited because they target only the viewport. But we usually operate in component-based worlds, and our components can change based on surroundings, different components that can be displayed, which are outside of our control sometimes. What if we could adjust the styles and layout of our components based on the available state instead? And we can do that with the container queries, which are currently part of the baseline and support in all major browsers. And it is one of the features that I rated about the most in CSS. I think it has amazing potential, especially in React applications. Look at all of that green in can I use, so we can already start using container queries in production. So container queries are based on the CSS containment spec, which defines approach to isolate specific DOM subtrees from the rest of the DOM to optimize layout, styles, and paintwork by the browser. It enables us to target specific containers. And for example, if our container grows in size, we can make sure that our children can readjust accordingly. Let's look at the example. So we have this postcard that just displays a post. It is a quite simple React component. We have some markup, and we have some CSS. However, if we try resizing this postcard, you can see that on larger sizes, it kind of start looking very, very odd. So it would be great to adjust the layout. Currently, we're using Flexbox in here, and we set direction to column. So it would be great to kind of flip it to row when we have more space to play with. Container queries are a great use case here. So in order to use the container query, we need to add a container. So we'll just wrap our postcard with the new div that would play as a container. And then we need to make sure it is recognized as a container. We can do it by defining on it container type. So in this case, we are defining container type as inline size, which means that it will target inline size, or width in our case. You can also set container type to size, which will then target both width and height. However, in most of the cases in the UIs, we actually need just the inline size. So it works for us. There's also a lot of other container types, but only size and inline size are widely supported right now. Now we can use this container to target all of the children elements inside. So we use container queries similarly to how we would do media queries. We'll just use keyword container, and then we can say what kind of condition we want to target. Usually if you start using container queries a lot, you can actually have a lot of container queries, containers nested within containers. So it is good to add some specificity. By default, the closest container is targeted, but we can name them to make it easier for us to work with. We can add it with the container name, and then we can specify this name when adding a container query. This way we can also target containers that are further up in the tree. There's also a shortcut syntax we can use, where we can define a name and the type of the container together. Now we can make adjustments to our layout. For example, here we'll change how the image looks, and we can see that our card now scales after a certain breakpoint. It changes the layout. And it's all done without using any media queries based on the available space alone. However, you can see that right now on really small width, it is really hard to read. So it would be great to maybe remove paragraph and text here that don't really make sense at this small width. And again, we can use container query here. We can just define a separate set of styles for smaller widths and remove certain elements that aren't readable at this size. And now our card can handle both really small and really big resolutions. Yay! And there's so many possibilities. I think with this example, we kind of just scratched the surface. So I really encourage you to research container queries. There's so many great things you can do with them. They fit right in with the component architecture and allow us to make component truly flexible and limit overrides by creating different versions. Given wide support, it's really good time to start experimenting with them. So, okay, now we have this amazing card. Let's talk a little bit about interactivity and responsive interactions. Let's say I want to display some kind of action menu on hover to perform some actions with my post. I will just render a set of icon buttons that can be clicked, and I will apply some styles here that just position them absolutely when hovered. So there will have opacity 0 by default, and when the whole card is hovered, we'll change opacity to 1. This works. You can see that right now all of the hover actions are available. This is something that we probably do day to day. However, if I now try tabbing through my interface with a keyboard, you can see that I'm kind of tabbing through, but there is nothing available. But the item is actually focused, we just cannot see it, which makes interface really hard to use for somebody using the keyboard. One way we could do that is we can make sure that opacity 0 doesn't apply when focus is within. So focus within pseudo-class is good and it works, you can see here, but we have one unfortunate side effect for mouse users. Now, if I'm using the mouse and I click on the action, no matter what I do afterward, before I move the focus to a different element, my actions stay displayed. So ideally, we would like to use focus visible in here. Unfortunately, the focus visible within pseudo-class doesn't exist, so we need to get creative. We can actually use has selector. Has selector is one of my favorite newer features in CSS. It's amazing. But here, it basically allows us to target parent based on certain states within the children. So now we just make sure that if anything inside our actions div has focus visible, it won't get opacity. And we kind of get best of both worlds. We have really seamless experience for mouse users. At the same time, you can clearly tab and see currently focused item with the keyboard. So we talked about mouse and keyboard. Currently, our card won't be actually interactable with touch devices, right? Because hover action is not possible on a mobile screen. So if you don't want your users to do this with their mobile phone anytime they use your app, we need to provide some kind of fallback. The way to do that, there's a media query that exists called hover. And if hover is available, so if any of the input devices connected to the computer has hover action available, then it will match. And so we can now hide all of our overlay styles under this media query and provide a fallback to just style our action nicely in a toolbar for mobile screens. And now, look at that. We have our card that works really well for both keyboard and mouse, but also we display our actions in a sidebar like that. So it's amazing, but let's talk about some other ways we can improve interactions. Especially with touch, there's a specific guidelines for target size. Because your finger is usually much bigger than a mouse cursor, so it can be hard to hit buttons. Minimum target size recommended is 24 pixels, but 40 pixels or 44 is actually ideal. So we used hover media query to target devices that support hover interaction. In order to target devices based on pointer size, we can use pointer media query. There's a lot of different devices out there. For example, like different remotes, like the one I actually have here. It has both hover interaction, but at the same time, a coarse or a larger pointer size. So now, if we, for example, have the pointer with less precision, we can change target sizes of our elements. And this is something we can do at our design system or component library level so that you don't need to think about it in day-to-day. Something that I like to do additionally to that is actually define certain variables for all of your kind of interactive elements so that you can then use them for any inputs, buttons, because you usually want them to be at the same size. Then you can see that when something is available or not, our elements become a little bit bigger, which makes it easier to use with any kind of larger pointers. There's actually quite a lot for responsive behaviors we can do at the level of our design system or component libraries to make experience more polished and fluid for users of different screens. For example, at our component level, we can make sure that the drop-down menu is displayed in a drawer instead of the pop-up to make it easier to reach with the finger when you're using a mobile phone. There's this, if you're using Radix, there's this amazing library called Wool that implements a drawer that actually supports different interactions, and this is built with it. So you can see if we're on a bigger device, we display a nested drop-down menu, but if we are now on a smaller device, we use this library to display this nice kind of drawer that we can use. We can use the same approach for any other elements that need like different dialogues or combo boxes, selects, and so on. Now we have this amazing card, so let's use it in some real interface. I would like to create some kind of feed for all of my posts to be able to view them all together. So we have this post feed component in here, and I would like them to be displayed in a grid. However, if you want to adjust for different viewport sizes, something that I often see being done is that you kind of just define different templates based on the viewport size using media queries. However, it's generally just more work, like just a lot more to type. But also, it has several other limitations. Because it targets the viewport size, if you have some other elements on the screens, like the sidebar, your layout actually wouldn't adjust. So we can use some more fluid layouts and let browser do all the work for us. For example, with grid specifically, we can define a specific function within the templates. So we say that repeat automatically. Then it can create as many columns as will fit within the container. And min-max is where the magic happens. So you can define minimum and maximum values. So minimum would be 15 rems, and maximum would be like available space for our column. And then browser will distribute extra space evenly when there's room for it. With it, we can create fluid layouts that don't rely on the viewports with just one line of CSS. And then it's also, because our cards are built in a responsive way, it's really easy for us to just toggle to the list view with just one additional line of CSS. With this, we can create like different layouts for components that adjust dynamically based on surrounding elements. Here in the sidebar, I actually would like something to show you as well. So we have the sidebar here. We are using this use breakpoint hook inside. To make sure that it's closed automatically for smaller viewports. But what I would love to talk about is the animation. So we have transition here that animates width when the sidebar opens and collapses. Here I'm playing it, slowing down. You can see that it kind of opens and collapses. But this animation is quite big. It causes the big layout shift. And some people prefer reduced motion due to vestibular disorders. And animations like this one can actually cause them feeling sick. And you don't want your UI to make somebody feel sick, right? So it would be very mindful of us to kind of create some kind of fallback and disable this animation. Something that I often see is that the transition is set to none when the prefers reduced motion setting is set to true. However, what I would suggest doing instead is just including animations only when there is no preference. Why? Because it's just generally less code to write. It is easier to maintain because you wouldn't forget to remove something after, for example, animation was adjusted. But also it's harder to forget to include the setting. So if you get into a habit of always adding anytime you have an animation, it just becomes a second nature. Now we have this animation by default, but if I go and open my preferences and set reduced motion, you can see that animation will be disabled. Yay, that's great. So far, for most of our responsive work, we use CSS. And this is great. This really aligns with the principle of least power, meaning choosing the least powerful tool for the job. So choosing HTML before CSS and choosing CSS before JavaScript. And generally, I think it's great to prefer CSS whenever you can, because it usually would be more performant because browser will do all the work. However, there are still some behaviors that we just can't do with CSS yet. So many applications have this kind of like interactions where you can see when the available space shrinks, different items and elements go into the overflow. So they kind of collapse or expand depending on the available space. In our web application from before, we have this available space. I would love to include some kind of filters there to filter my post by different items. So I want to filter like by tags, type of the post, who created it, and so on. And we have some drop-down components that we can use already. However, we need to build this overflow logic for it to adjust consistently. So let's think about it first. We have a list of items we need to display, And we have a container we want to display them in. So we can try to fit them in there, and then we need to see that which ones don't fit, right? And they should go into the overflow. And if we have anything in the overflow, we should display an overflow menu that displays those options. Yeah, you see what happened there? Like we added the overflow menu, and now another item doesn't fit anymore. So we need to make sure that we account for the width of the overflow menu as well. So now this item needs to move to the overflow as well. That's great, but web is very flexible, right? So the size of our container can change as well. And so some items can dynamically either not fit or start fitting into the container. But also size of our items can change, right? For example, label with changes, or somebody turns on translation feature in the browser. So we need to be able to adjust it. For example, here right now, another item would actually fit. So there's quite a lot to account for. Let's look at our requirements. So we want to be able to fit as many filters as you want. We want to be able to add more new filters in the future, and we don't want to think about it. So any hard-coded solutions in CSS, if this and that, don't work. We also want to support dynamic values. So we also cannot hard-code any of the specific sizes for our gaps, buttons, and so on. And we should rely only on available space. So let's get started. So we have our component, which is empty right now. So the first thing we can do is what container queries do. We just need to measure our container to at least understand how many space do we have. To do that, we can add a ref, which gives us access to the DOM node. We also need to store the width somewhere. And then we can measure it by accessing the bounding client rect on this DOM element and setting our width and putting it in state. Now we are displaying it in there. You can see that it is initially calculated, but it doesn't recalculate when we resize the element. So in order to do that, we can use Resize Observer API. It is kind of like a window on resize, but on the specific element. So we can provide an element we want to observe, and then make our updates in the callback when the dimensions change. For example, here we are setting the one observer container, and we disconnect when component unmounts. Even better, we can extract this whole logic into a separate hook and just use resize observer hook, which looks quite neat. Now, if we resize our element, you can see that it's dynamically recalculated, and we see the width. Of course, these kind of operations can be costly. So ideally in production environment, you will add some kind of debounds to make sure it doesn't recalculate too often. So now we have the width of the container, right? Additionally, we also need to measure width of each of the items, and they all can have different widths, right? And we need not to forget about the size of the overflow menu, which also can change. For example, if our target size changes based on the viewport. And we need to account the gaps, right? So it's kind of a lot of math. So let's get started. We can start with the TypeScript type. So we know that we need width of the filter items, our overflow button, and the gap. This should be enough together with the container width for us to calculate what we need. So how we can do it? So we could, for example, create and kind of render them and put individual refs. Or we could create one kind of hidden container that we'll use for measurements. And this is what we will do here. So we can create a different ref that we'll use for measurement the same as with our other container. We'll need to store those measurements somewhere in state. And now we can just render our buttons that we want to see. Like we render all of the filter buttons together with the overflow menu. In order for it to still be measurable, we can set visibility hidden and position absolute. So it will still stay within the DOM and will have dimensions, but it will be hidden. Alternatively, and probably even better, it will be to render it in a portal, but we'll keep it simple right now. So now we can use the same use resize observer hook here to calculate the measurements and see how they change. Now to the fun part. So we already have our element, the container itself. We can get the total width of the container And through access to the DOM, we can get all of the children elements that are rendered within. So now, because we have width of all of the individual elements within the container, we can calculate the width of all our filter items and overflow button. Because overflow button is always last, we just filter all by last for our filter items and get the last width for the overflow button. Now the last thing I got to do is the gap. We can dynamically calculate gap by getting width of all of the items summed. Then we can subtract it from our total width and divide by the number of elements that we have. So now we have all of the dimensions. And we set them in state so they are available. The only thing left for us to do is to understand which is the last element that can fit within our container. We can calculate it by this chunk of quite imperative code, but it's actually quite simple. It's very similar to the process that we did in the beginning when we just tried to fit different things inside the container. So we'll just iterate through all of our filter items. We'll add them to the total width of occupied space together with the gap. And then if it doesn't fit, so if together with the overflow button becomes bigger than the container width, we know that this is the last element. Previous element was the last element that we could display. If none of these are returned, we know that all items could be displayed. Now the only thing left to do is just filter items based on index. So we now have our list of visible filters and overflow filters. And we can display our combo boxes for visible filters and get into the drop-down sub-menus for our overflow filters. And yay! This looks we are resizing, and we have more things that are displayed as we resize the element, and works dynamically. The solution, of course, is not fully complete and is a little bit naive, but it shows how we can use JavaScript for some behaviors that we cannot achieve with CSS. Now, putting everything together, we have built this application, and we actually haven't used a single media query in our CSS. So we use container queries, and everything relies on the available space and automatically adjusts. And because we also thought about touch interactions, everything works for touch devices as well. We have these beautiful drawers displayed on a menu. We have filters that work, and you can adjust them on the mobile screen, which is amazing. And this is the last example that I wanted to cover. Throughout the talk, we kind of talked about a lot of things. So we covered responsive and fluid typography. We learned to use CSS container queries. Talked about breakpoints and media queries, supporting different types of interactions with the keyboard, touch, different pointer sizes. And also learned to build some responsive components using JavaScript as well. And this is where I would like to wrap up. So thank you. I hope you found this useful.